let us try to solve this problem. Let x is equal to y of x be the solution of the curve, uh, that is differential equation here, and satisfying y of 0 is equal to 1. Okay, this curve intersects the x-axis at point whose abscissa is. Okay, so let us try to find the solution of this problem. So our equation was, the differential equation was y square minus x into dy by dx is equal to 1 for y of 0, which is 1, which is given. Now let us solve this. Now we have to make this in the form of a linear differential equation, which is uh, in the form of a dx by dy plus p into x is equal to q. Okay, so where p is p of y and q is q of y. Okay, the function of y. So let us try to uh, look into this differential equation here. So this can be written as now this goes to the right hand side. So this becomes y square minus x into uh, that is equal to dx by dy, or we can rewrite this in the in this. So dx by dy plus x, bring x to the right hand side, and this is equal to y square. Now this, if you look at this, this is the equation which I want to perform. Now to find the solution of this, first we have to find what is integrating factor. Integrating factor would be, uh, if you compare this, so p is equal to 1 and q is y square. Integrating factor, which is e to the power of integral dy is equal to e to the power of y. Okay, so integration of dy will be y. So we got the integrating factor. Now now we know that x into integrating factor is equal to integral, that is q of x, which is y square, okay, into the integrating factor plus c. So that is x into integrating factor, which is e to the power of y, okay, integral y square into e to the power of y plus c. Okay, so let us solve this e to the power of y, and this integration will be y square minus, okay, 2y plus 2 into e to the power of y plus c. Okay, now we have been given that y of 0 is equal to 1. So here this means that x is equal to 0, y will be 1. Okay, let us substitute that. So x on the left hand side, which is if I put x is equal to 0, so this is 0 and this is 1, y is 1, and this is 2 and this is 2, and e to the power of y, so which is e plus c. So you can cancel these out. So we get e is minus c, or we can write c as we want c, which is constant, which is equal to minus e. Now we got this, and now let us substitute in this equation. Okay, I call this as 1. Okay, let us substitute that. So when I substitute it, we get x e to the power of y is equal to y square minus 2y plus 2 into e to the power of y minus e. Okay, now in the question it was asked that since the curve intersects at x-axis, so the curve intersects at x-axis. So when the curve intersects at x-axis, y will be 0. So what you see is this, okay, here somewhere on the x-axis. Okay, this there will be a curve. Okay, so let us substitute this uh, y as 0. So x e to the power of 0, which is 1. Okay, and this 0 minus 0 plus 2 into this is e to the power of 0, which is 1, right? Minus e, or x is equal to 2 minus e. So this is the required result.